That's good. So I'll put that on the Facebook, and I'll claim that you have come just to listen to me here, even though I know that it's unpolite to leave a session in the middle of everything, right? So thank you for that. I'm happy to be here. My name is Richard Haagensen, half Swedish, half Danish, live in Finland, so let's not that disturb you too much. I will speak a little bit about smart grids, right? And from the utility point of view, what does it mean, and what could be a pathway to go into getting a smart grid, to be prepared for the smart grid, and why it is important to consider standardization and part of that, and what does IEC provide to the utility. So basically, we all know that from the utility's point of view, going from a very bundled, integrated market to a very top-down generation point of view, at the moment we can see unbundling a lot in the European market, where we are talking about, and a need to change the business models, right? And how do you change the business models? Basically, you need to get transparency in what you're doing. From utility point of view, we know that the pressure from legislation is quite hard. There's a lot of renewables coming into the utility, a lot of uncertainties to manage, right? So we need to get some transparency into the grid, right? So we can't just make assumptions how things are going to work. And the transparency you need in order to get data out of your network and all the devices that you have in there, so that you can make business decisions and then adopt your business models and business processes. So we have talked now, and Svetlana did also talk a lot about the bottom part of this picture, the technology. I mean, this is very technology-driven business at the moment. We're talking a lot about different kind of new technologies, not only for smart metering, but smart sensors. We talk about smart community, all kind of stuff, and a lot of it is based on, at the moment in Europe, about what kind of communication technology should we use and so on. And there is not one solution that fits everybody, right? So there will be a lot of different new technologies today and tomorrow, and it will evolve, right? As well as from a business process point of view, I mean, driven by legislation means that you have to do certain business processes first, necessarily, and then you want to take care about the other business processes. And in an unbundled market, obviously, you will have a lot of more stakeholders that you need to serve. So marrying these two needs, in the middle there somewhere, there will be a solution architecture. Like today we call that advanced metering management or infrastructure architecture for smart metering. That's the starting point, and tomorrow we will call that smart grid. Once we put new technologies, other business processes in there. Whatever we talk about, it's important that once we do the investments right now, that we start up and we find a pathway to make that more future-proof, right? So that you can go into managing your business process, not like a silo. So not traditionally what we make from an operational technology point of view, looking at only smart metering, putting in an infrastructure for that, putting applications for that, and then jumping into the next process, business process. That will not be sustainable. Everybody knows that. And how do you then put in something in the middle there that would allow you to get a benefit, more than one-to-one benefit, right? So how can you benefit more in the different processes? So that's the main question. I mean, that how can you invest in order for things that you don't really know what you need in the future? For sure, we know that the goal of this whole exercise will be that our business model will change, right? So we need to be able to, as a utility, to prepare for business innovation, right? And that will go very rapidly compared to what it has been doing the last 100 years. So that means, first of all, that we need to separate the data model from the infrastructure, you know. So technology by all means, but we need to get the data out of that, and we need to start to merge the data together internally in the company as well as externally, right? To start to get to be able to make business decisions based on that data. So data-driven decisions. So how do we do that? Yes, first of all, we need to hide the underlying technologies, data acquisition, smart metering, for example. So hide that and separate that from the actual data model. And unfortunately, this is done on the IT level, right? And from a utility point of view, that might be a new place to go in and look into. But and that's more complex typically than the device level. So communication technologies and those interfaces and so on are typically quite simple compared to IT infrastructure. So typically reference architecture that we talk about in the industry today is the following picture, right? Where you consider the smart devices as one entity, you then put the collection systems on top of that, or the head-end systems. You separate that from the metadata management system or grid management systems, whatever you would like to call them, and then the advanced business application that you would like to innovate on top of that. And you put integration layers in between there in order to get this separation between in the data models and independency between the different systems. And obviously on the right hand, the target then where you want to bring in is not maybe that you want to make business applications for every process to start with, but you will probably, you have systems, legacy systems, you will have new systems for billing, for outage management, for demand response, whatever you call it, right? So you will have other systems. So that's the typical reference architecture you speak about. And how would you then continue to make an efficient implementation of this one? This is still just a paper exercise so far. So for an efficient implementations, efficiency, what is efficiency first of all? Yes, the requirements for efficiency is pretty simple. First of all, in this architecture, we need to define the system boundaries, right? Okay, what does this system do and what doesn't it do, right? So what is the roles and responsibility? Obviously, a cost for such a system will be defined very much about the integration points, the interfaces, right? What are the interfaces? What are the integrations I need to do? How much do I cost to put them in place, and how do I maintain them, right? There's a lot of cost in there. Could be for a smart metering project, could be 5, it could be 15% of the whole rollout, for example. So there's a lot of costs related to this one. And from a standardization point of view, then you need to consider what are standard interfaces from a vendor point of view, what are supported in the market, and try to limit those to those. And then what you want to have is the common data model or the semantic model, right? So that the interfaces know and can speak with each other, so you don't need to do, you know, point-to-point integrations and legacy, and bring that kind of a technical depth with you as you go forward in the future. Don't reinvent, obviously, so use what we have, use what is in, learn from other industries, learn from your own industry, and communicate the data and store that in the same way, more or less. That's the big data concept will force us into this, that unless we unify the data somehow, we will not be able to utilize that for our decisions. What I'm saying then is that the software that we put in place, that we have to consider that we need to choose something as nice as a software for the future, right? To solve the problems of today. That's what we need to do. So we need to think about what is the key here. The key for us is that the software in this architecture will play an critical role for integrating the utility systems, right? To bring you from where we are today, we call them legacy systems, whether or not we like that, and bring us into the future. So that will be the key, right? And the goals is that we need to structure that. We need to structure that. We need to get interoperability. So not only integratability, but interoperability to maximize the return of investment that we do, right? So that we can reuse what we put in today for the future. So how do we do that then? That's really a good question. We're saying that a boring topic as standards will help you in this, right? So how can a standard help me in my business? Yeah, that's what it's designed to do, right? So it's designed to solve the problem in a standard way, to give some support for you as a utility, and enable vendors then to provide and compete with products according to that standard, right? But the problem is, of course, as we said, from Svetlana said here also, that the maturity of standards and the evolving of standards might take some time, right? So how do we know which one to pick and choose, right? And that's then the question where we as Toshiba, Landis+Gyr and friends and colleagues in the vendor industry can come in, right? So basically, we need to enable an end-to-end solution, right? So software only will not help you. So how do we do that? Yeah, basically by picking the right standards. So choosing the right standards, that will make you more efficient, right? And that will lower the cost of your investments and lower the life cycle cost also for your solutions. So basically what we want to achieve is pre-integration, right? So you want to buy out-of-the-box products, you want to buy out-of-the-box software, pre-integrated, pre-tested as much as possible, right? So it's might be a more higher upfront cost, but it will save you in the life cycle quite quickly, payback in 2-3 years easily. So what we do in the industry then, and we focus very much on the IT part of it. We focus very much about standards that are proven. We work very much with the IEC standards, IEC standards for both the operational technology, smart metering, SCADA systems, and so on, in communication, of course, as we have done many years. And on the IT standards, it's the IEC 61968 that is trying to cover the IT part of it. This we have done also very much in North America already, where we have utilized this standard and it's proven in the market, and there's a lot of support for that already. And IEC 61968, which is a part of it, is a picture trying to describe what it is. So this standard will then, on one hand, it will on the bottom right here, it defines a common interface model. So it defines the data model to harmonize the data in these interfaces. And then we have split up in the industry. We have split up then from a utility point of view the different business area we see as internal today, from smart meter reading and control. That's the starting point where we are today, the part 9, but not excluding any other of the internal processes, right? So each of these interface parts will then define what this software is supposed to do as a minimum, right, as a standard. And then the interface models and the data model is extendable also, of course, to fit the needs of the future. There will be also a part defining the external world also, because not only things are internal processes. We need to work with retailers. We need to work with the market, and how do we communicate with them. So that is defined also, how that should be done in the standard. In the European market, we work very much based on legislation, so it's good to understand how these are then fit together. So from the European Union, they have issued, on one hand, a smart metering mandate, and on the other hand, a smart grid mandate, right? So that's the way to push into the market the mandates. What these groups that have been defined, what are they doing? These groups are more or less trying to utilize and defining the standards in Europe, what we should use as a utility and as a vendors to solve this problem. So you can see that in the middle there we have the Senelec, which is more or less the IEC IEC standard in here. And then as a part of those working groups, we have two working groups, the Smart Metering Coordination Group and the Smart Grid Coordination Group. These groups are then where we work in order to apply those standards and define the use cases for the specific industry, right? And a big part of our commitment then as Toshiba, Landis+Gyr, as well as our dear friends and colleagues in the industry, we work in the European Smart Metering Industry Group, the ESME group, where we have working groups supporting these groups. Participating is in this coordination group and defining use cases and also implementing them in our products, right? So that's kind of the ecosystem, how we work to push the standards into the products, into the industry, in our commitment to the industry, right? So from Landis+Gyr point of view, then we will have, and we have a booth here also. You're welcome very much down and have more discussions and see the products. Of course, our products fits into this. This architecture, obviously, we leverage the IEC standards on all levels. On the operational technology on the bottom there, smart metering, SCADA-enabled devices, on the software, on the hidden system, on the MDM and the applications, right? And can also work very interoperable with other vendors. So that's more or less what Landis+Gyr Toshiba will bring to the industry, and it's our commitment. You know, making a standard fly in the industry and among vendors is not an easy task, and it's not a cheap task either, right? And that's then what we as vendors will provide as a pathway towards the smart grid on one hand, and our vision will be towards the smart community in the future. Thank you very much.
Thank you very much, Richard, for a very inspiring presentation. I'm sure there will be a lot of questions. So again, we have time for 1 or 2 questions. So please indicate if you have a question, and I will come around with a microphone.
My name is Jørn Engberg from NT, a Norwegian utility company. How much is it used in Europe now? This common interface model. Do you have any references using this model in European utilities?
Yes, we do. We do use, of course, from an IEC point of view, that's used very much in meters and communications. From the common interface model, we use that in our software. We use that in Switzerland in some utilities already now. We work also with other companies in Germany to push that into there. So there would be in place at the moment. I would tens of utilities are using this software for integration. We have to remember that this integration layer, this common interface model, will not take care about the legacy systems, right? And today, very many of the billing systems, which is the main focus of the smart metering rollout as in the step 1, is legacy systems, right? And changing them to use the common interface model is not seen to be very cheap, right? So that won't work, right? So we use common interface model preferably in new interfaces. We work in the Finnish market. We do network management system integrations with ABB, for example, and there we have a common interface using IEC, and that's running in a few utilities in Finland. And in Switzerland, we do that between the vendors, head and system MDM vendors, with different vendors there also. So it's coming more and more. The biggest market for that is, of course, in North America. So you will hear the reference to SIM, which is the model, right? And the IEC standard is defining that model. And that's in almost all utilities running at the moment. And there are, tens of millions of metering points and IT systems supporting that, using that already today. Yes.
Okay. Then I would like to thank Richard.
Thank you very much.
So thank you very much, Richard.
And thanks for coming to listen to me.